So here's part C of 2004 Form B, AB number 4. And you have the graph of f prime provided here. You have different characteristics about f, f prime, f double prime described in the problem statement. And in part C, it defines a new function. It says g is going to be the function defined as g of x equals x times f of x. So they give us a new function in part C here. And they want us to find an equation for the line tangent to the graph of g at x equals 2. So our answer should be in either point slope form, slope intercept form, most likely. To construct that, we're going to need to know a point on the line, and we're also going to need to know its slope. Since we need to be tangent to the graph of g, we're going to need to know the slope of a tangent line to the graph of g at the x value of 2, and that's going to correspond to g prime of 2. Before we can find g prime of 2, we need g prime of x. And so this is a little different, but not that difficult as long as you're careful. If you look at how g of x is defined, it's defined as the product of two functions of x. A simple one, x, and one that we don't really know, f of x. But since it's a product, to find g prime, we're going to have to use the product rule. So the product rule is going to tell us to take the derivative of the first piece of the product, multiply by the original second piece of the product, add to that the original first piece of the product, and then multiply by the derivative of the second piece of the product, and the derivative of f of x will be f prime of x. And so what we have here is we have g prime. And what we found g prime in order to do was to establish what the slope of the tangent line to g was at the x value of 2. So now we're going to need to evaluate g prime of 2. So g prime of 2 is going to end up being, well, the 1 isn't really doing anything when I multiply f of x by it, so I'm just going to put 2 in place of all of my x's in my derivative for g. So I'm looking at f of 2 plus 2 times f prime of 2. If you think about it, everything that we need is either provided or we'll be able to steal from the graph. We need f of 2. And up here it told us what f of 2 was. It told us that f of 2 was 6. So since f of 2 is 6, we can go ahead and we can put 6 right in place of f of 2. And then we're going to add to that 2 times f prime of 2. So what is f prime of 2? Well, think about it. This is a graph of f prime. At 2, the value of f prime is negative 1. So we're looking at 2 times negative 1 there. And if you simplify that, that's 6 plus negative 2. 6 minus 2 is going to give you a slope of 4. So the slope of our tangent line to g evaluated at the x value of 2 is going to be 4. So we now know our slope. We also need to know our point of tangency. Our point of tangency, or the point on our line, is going to be 2, comma, and since we're tangent to g, it's got to be g of 2. So what is g of 2? Well, we don't know that right now, but it's easy to find if you're careful. G of 2 is going to correspond to putting 2 here and putting 2 here. So we're putting a 2 in place of the x in the definition of g, and we're also going to put 2 in place of this x, which ends up being f of 2. So this says 2 times f of 2. Well, f of 2, we just used that to find the slope a minute ago. F of 2 is 6. So this is going to be 2 times 6. And 2 times 6, of course, is going to end up being 12. So our point of tangency is 2 comma 12. So to conclude, what we need to do is we need to write the equation of a line that has a slope of 4 and goes through the point of tangency 2 comma 12. If you use point slope form, we're going to do y minus y1. So y minus 12 equals m, which is 4, times the quantity x minus x1, which is 2. So you can do it in point slope like I just did. If you preferred to use slope intercept, you could do that too. Either way you do it, you end up with the equation of your tangent line.